So here we've got sticks of different lengths. The first stick has two lengths that are 2 and one length that is 1. And it could be a decimeter. These, every one represents 5 centimeters in my sketch here. Okay, could we build a triangle with the dimensions 2, 2, 1? Well, yes, we could, because if we take our biggest length here, 2, and then we compare it, these other two here, they have to actually be longer than 2. If we add 2 and 1 together, we get 3. So that tells us that we can build that triangle. We could build it quite simply by having the 2 long ones like that and the smaller one like this. So this would give us an isosceles triangle. These 2 lengths would be the same, these 2 angles would be the same. So a triangle with the dimensions 2, 2, 1, yes, we could absolutely build it. What about one where we have a 3 centimeter long here and then 1, 1? Well, if we add 1 and 1 together, we only get 2. And the base is going to be 3 centimeters. So there's no way we could build a triangle like that. Because, look, they're never going to meet. It's going to be a big, long baseline and 2 small lines on top. We can't build a triangle with those figures. So no, that triangle is impossible to build. There's no way we could do it, even if we put the 1 on the bottom here. Okay, and we put the 3 centimeter here. Let's say we put the 3 centimeter there. We try to meet with this other 1 centimeter, it's never going to meet. So we can't build a triangle that when you add up the 2 smaller lengths, they have to be longer than the other length. We've also got a problem here. If we add up 2 and 1, we get 3. 3 is exactly the same as 3, so we won't be able to build that triangle either. Because if it's exactly the same, there's only one way it can be built. The stick 3 centimeters will go on, the 2 and the 1 can go on top of the 3 centimeters, but they're never going to meet. We can't. They'll meet, but they won't be able to build a triangle. We won't be able to get an angle in there. They can only go flat on top, and then they will not be able to build a triangle. So if the sum of the 2 smaller angles is not equal, is not more than the longer one, we can't build a triangle from. What about 2, 2, 2? Well, 2 and 2 gives us 4. So 4 is longer than 2 centimeters. So yes, of course, we'd be able to build a triangle where all the lengths and the sides were the same. This will give us an equilateral triangle. All the angles will be the same and all the sides will have the same length. And we know that the angle of an equilateral triangle is always that all angles are 60 degrees. So of course we can build a triangle where the lengths are the same. What about 3, 2, 2? Well, here's our longest one. If we add the other 2 lengths, we get 2 and 2, which is 4. So yes, this one is absolutely possible to build. We could have a 3 centimeter base, and then we could have 2 slightly smaller lengths that are identical. This would give us another isosceles triangle where this is 2, and the base is 3. So we know that these 2 angles will be identical, and we know that the base will be longer. We don't know exactly what they are unless we measure them up, but we do know that they'll be the same. Okay? So if this angle is x, this angle is also x. And which angle is this? This angle must be 180 minus 2 logs of x, because all of these angles add up to be 180. So there we are, investigating again what we can and can't do with matches. And this is another good thing to practice and play and have fun with at home.